Hello everyone, I'm back with the vector chapter, and today we are going to learn about some special points and some special cases in vectors. Before that, let us again recapitulate everything fastly. So, what are the things basically to be a vector? It should follow three things. It must have magnitude, it should have direction, and also it must follow vector addition law or vector addition algebra law. Okay. Now then comes types of vectors. Okay, so basically we learned 12 types of vectors. I will just name it fastly. First comes parallel vectors, second anti-parallel, third equal vectors, fourth one uh, negative or opposite vectors, fifth unit vector, then collinear vectors, coplanar vectors, axial vectors, polar vectors, concurrent vector, null vector, etc. Most important of them for here is unit vector. Okay, unit vector is basically vector which has a magnitude of 1 and it is represented by the given symbol and a cap over it. Okay, there is a cap given above the given vector, which means that it shows only the direction and it has a magnitude of 1. Okay, remember this point. Then we talked about angle between two vectors. Angle between two vectors is there were two cases when it is true. Okay, first comes when the head to head is connected or the tail to tail is connected to each other. Okay, then only the given angle will be considered. Okay, but if head of one vector and tail of another vector is connected to each other, then it will be not considered. Or let me just give you example. See here, I am having, suppose these are two vectors. Okay, this is the tail of one vector and head of this vector, and this one is the tail and head of another. See, if it is connected like this, okay, tail to tail is connected to each other, so the angle made by them is considered. Or if the head to head means basically like this, it is connected, then also the angle will be considered. But if it is connected like this, see, head of one vector is connected and tail of another vector, so this will be not considered. In this case, we move the vector parallelly. See, I'll just move this vector and put it here, so neither the direction has changed nor the magnitude. Now this angle will be considered. Okay, so this is how angle between vectors are calculated. Now next we talked about laws, vector addition laws. So two laws we studied about, triangle law and parallelogram law. In triangle law, two vectors must be connected in same order. Same order basically means head of one vector and tail of another vector. Okay, now two vectors must be connected in same order, and then the third vector will be its resultant vector in the opposite order. Okay, now another law we studied about was the parallelogram law, in which two vectors basically makes a parallelogram, and the diagonal of the parallelogram, okay, represents its resultant vector. Okay, then we studied the mathematical formula, which is result r is equal to, or resultant vector is equal to, root over a square plus b square plus 2ab cos theta, where theta is the angle made by the two vectors. Okay, that's how resultant vector is found. And we also studied the formula about the angle which we have to find, which can be find with the help of it between the resultant vector formed and the given vectors. Okay, it was basically tan alpha b sin theta by a plus b cos theta. For example, we have to find the angle between the vector a and the resultant vector. So a vector value will be written in the denominator, or basically a plus b cos theta is there, so a will be written in the denominator, and similarly for goes for the another also. Okay, next thing comes is there are some special cases. Okay, if vector a and vector b are parallel to each other, then the resultant vector can be maximum value of a plus b. Okay, where a and b are the magnitude. I am just defining the range. And also if vector a and vector b are anti-parallel, then minimum value of the vector can be, resultant vector can be A difference B. Okay. Now next thing comes is when two vectors are perpendicular to each other, then resultant vector can be directly found by the formula root over A square plus B square. Okay. See, it is just the formula of Pythagoras theorem, like h square is equal to b square plus p square, so h equals p square plus b square whole under root. Similarly here, resultant vector is equal to root over a square plus b square. Now another type of special case is addition of two equal vectors. When the given vectors are equal in magnitude, okay, then we directly use the formula r equals 2a cos theta by 2. Okay. Then there is one more special case. If the two vectors are equal to each other and their magnitude and the angle given between them, between the two vectors is 120 degree, then the resultant vector will also be the same. Or let us see one question here. This will help you to visualize better. Okay. See, this is basically the thing. Okay. If if two vectors have same magnitude and angle between them is 120 degree, then their magnitude of resultant vector is also the same, and resultant of the two vectors of equal magnitude will be at their bisector. See, this one is the example. Okay. These are two vectors and angle between them is 120 degree. So this resultant vector will be at the bisector. This will be also 60 degree and this will be also be 60 degree. Now let us see the question here. See, there is vector A, given magnitude of vector A is 10 Newton and magnitude of vector B is also 10 Newton, and theta given between them is 120 degree. So if two vectors are equal in magnitude, we use the formula r equals 2a cos theta by 2. Okay. So here A is 10 newtons, here it is also 10 newtons. So 2 into 10 newtons cos theta by 2, theta is given 120, so theta by 2, it will be cos 60 degree. Okay. So 2 into 10 into cos 60's value is 1 by 2, so it will give us 2 will get cancelled and this will be 10 Newton. See, vectors magnitude, both the vectors of magnitude 10 Newton is there and resultant is also of 10 Newtons. Okay. So it is, we can just simplify in this way. That's all for today. Thank you.